Conradie is the executive founder of LifeQ. Riaan's passion is understanding how systems work, which has led him to a deep understanding of a broad range of areas spanning biology, physics, math, engineering, and design. Riaan has firsthand experience of the impact of disease. As a young boy, Riaan lost his eye to retinoblastoma. Sorry about that. Butchered that word. Soon after completing his PhD, Riaan realized that by combining his special knowledge in computational systems biology with his entrepreneurial spirit, there was an opportunity to make a real difference in how the world managed health. Over the past 5 years, Riaan, with a 40-plus multidisciplinary team, has been working with strategic and technology partners, third-party developers, and research hubs to develop a biotechnological platform that could bring his dream to reality. Please welcome Riaan Conradie.
Thank you, Julie. I'm going to get the clicker, see if it works. Cool. So I'm going to talk more about tapping into the human sensor. This talk is not going to be that wearable device focused, even though wearable devices are imperative to get this going. It's all about turning data into very valuable information streams. If I look at just mobile health in general and just how wearable devices and all these things are progressing in time, it's very much like weather forecasting. Long ago, you had to go out of your house and actually feel the rain on your head or look out of your shelter to see whether it's raining. And that's probably not the ideal way of doing it. It's always good to have some type of forecast. And so people came up with very interesting ideas. For instance, one of the devices that they created for weather forecasting was the very humble barometer. And the barometer is very interesting because you can monitor small changes in pressure, and you can actually infer how the weather is going to change, whether it's deteriorating or improving, whether it's going to rain or not. Not perfect, but it's a huge step ahead from where you had to go out of your house and actually get wet or just look out of your shelter. But subsequent to that, we had climatologists and a lot of scientists all over the world working together to build very sophisticated models. And I'm not going to delve very deep into this because first and foremost, I'm a biochemist and not a climatologist, so I might talk a lot of nonsense to you. But one thing that I can say, these are highly complicated systems that people over time understood. And these models are highly sophisticated now, to the point where they can, with these simulations, go back in time and even see spikes where, for instance, the Ice Age happened. That's how advanced we are with this type of forecasting. Nonetheless, you know, every now and then you go out of your house and things aren't as they are predicted. Mobile health is following a very similar type of evolution. And not very long ago, you had to go to your doctor, to your physician, some type of coach, and get some snapshot of where you are. So you went running, for instance, as someone that's highly interested in fitness and maintaining and improving your body. But it was very difficult to know how hard should I run before I, for instance, get overtrained? How can I stay in that point of functional overreaching? There's all these aspects where people just got a single snapshot, a point snapshot. This brings me to the next wave, and I just went to one of the halls with a lot of booths, and I was just overwhelmed by the vast number of devices out there. It's metrics everywhere, it's data being spit out to people, without people really knowing what to do with all this information. And that brings me to just the next bit, where I think we are at an exceptionally interesting inflection point. Everyone sitting here is part of this journey, and we are seeing this actually happening in real time, and this is very much how our company LifeQ is doing it, but there's different approaches, and these approaches can be very synergistic as well. But what we do, we use continuous body monitoring So I, for instance, have, just want to show you quickly a device around my arm. This is just a research prototype that we've developed, where you can see very interesting metrics like heart rate, VO2, your post-exercise oxygen consumption, blood lactate levels, things like that. And we do that by feeding this data into what we call this computational systems biology platform. So I did my PhD in biochemistry, specifically focusing on computational systems biology, and I got extremely excited when I saw these vast amounts of mathematical models arising, and all these things just culminating in research papers, not really getting out there into the applied world. And I think it's probably also a symptom of wearables not being ready to serve these highly sophisticated models. So in about a 4 or 5 year period, we did the effort of taking all these mathematical models in literature, generalizing them, breaking assumptions around these models. For instance, you will have a model that's specifically built for a very set condition, like in the ICU or for extreme VO2 max testing, and we generalize these models into one comprehensive physiological model. So you feed that continuous data to that model, and then we can build a digital representation or a digital simulation of each and every individual in the cloud. So where there actually lives a digital copy of your metabolism and your physiology in the cloud that you can start interrogating, doing very interesting stuff with. So I think this is really, there's a lot of different approaches. There's machine learning approaches, artificial intelligence approaches, and these things are not mutually exclusive. I very much see this as for instance, a Lego block that can latch into all these different platforms out there. So the future of wearables, as you've probably noticed now, is not necessarily wearables per se. And the per se is very important there, because wearables, just like the barometer and the traditional measuring equipment in weather forecasting, still quite important. But you can do so much more with that data if you contextualize it within a mathematical framework that describes human physiology. Over the last 100 to 150 years, we've collected vast amounts of information. And in the last, I would say, 10 years, researchers have been extremely active to build very interesting models around this. What we've done is we've simply brought these things together into one comprehensive model, as mentioned. So I want to use another analogy, and that is about recombining matter. Over the last 100 years, humans have been extremely clever to take different properties of materials. I mean, I get so excited when I read about stuff like graphene being used for, it seems like, for pretty much anything out there. But there's all these materials that are being made with very specific properties by material scientists. But that's just the parts. The really interesting stuff is when you start to combine these things to make some type of functional product, to make something like, for instance, a wearable. I think, though, it does not stop at the realm of matter, the realm of the physical world. It's very much where I think Fitness Generation 2 can be inspired by recombining data, where data is the new Legos, where we can start using these different bits of information and make really valuable output. Remember that picture of the car parts combined into something extremely functional? Data is still in its parts. If you have a metric or you have a specific data being pushed to the individual, it's very dead. And I think we will see it more and more at CES as well every year, that people will become resistant to all this data streams and all this metrics. People would want more value, actionable insights from there. And the car that I just showed you there, built from all these pieces, I think the equivalent of data is actionable insights. It's giving knowledge to people to really truly understand your body. One example that I use that really nails it, I think, is the one that you wake up in the morning after a terrible night of sleep, and you check some other wearable saying, listen, you had 5 hours of terrible sleep. It's just adding insult to injury. It's not helping anyone. And I think this is where a mathematical framework like the one we are working on can really change things. It's to turn all these bits of data and information into actionable insights that people can react upon. And not just react upon, but where people can truly understand their own physiologies and their own body. So what we do is, and I think this is the critical or the key difference, is for computational biologists, and pardon if I speak on behalf of all of them, but at least how I see it is, the wearable is not the sensor. The human is the sensor. We are extremely sophisticated sensors in the world. We react in very specific ways. If you go and run, your heart rate will adapt, your breathing rate will adapt. In essence, you just created a very complicated output from an input to a highly sophisticated sensor. And as we see the human as the sensor, we see the subsequent step is to collect data, to get data streams from that individual. We call, in our company, LifeQ, we call that step that we are working on the LifeQ lens. Just to briefly touch on that, we, for instance, developed an optical sensor called the LifeQ lens. There's several different things we are working on the sensor side. But if you look at the optical sensor, when we started, we looked at the computational biology, and we got this framework. We needed some inputs going in to get to personalize these models. We couldn't find anything out there that was accurate enough for our needs. And we said, let's not follow an engineering approach. Let's see the human as the sensor, and let's use the biology to build this lens technology. So we built highly complicated models of the different skin layers. For instance, how light will react with these different skin layers, how light will reflect back to, for instance, a photodiode or some type of photo sensor, and how you can use that information then with a lot of biological knowledge to get output, some metric output. But then subsequently, we also have the LifeQ core. So the LifeQ core is divided into two components. On the one side, it's a lot of biologically inspired algorithms running on your embedded system, on the wearable, which any wearable device company can integrate in their wearables now. And these things give output like blood lactate, epoch, VO2 max. Our VO2 max test, for instance, is slightly more accurate even than a sub-maximal VO2 max test that you will do in an exercise physiology laboratory. On the other side, we also have the cloud-based part of the LifeQ core, because you can't fit all these heavy computation on your device. So we need those data streams to our platform, and then we can start doing really interesting stuff. One that we've just showcased was using a few base measures such as heart rate and breathing rate, and deducing a very complicated output called respiratory quotient, telling you how much oxygen versus carbon dioxide ratio you are actually using and producing respectively when you are exercising. So now I can, for instance, not just say what my energy expenditure is, but I can even say whether that is carbohydrates or whether that is fats that I'm using for that specific activity. Then the really exciting side is the personalized suggestions. And we by no means think we know it all. That's why we work with industry partners, hospitals, non-civilian military organizations, for instance, sleep clinics. There's a bunch of different experts we work with that we would enable as much as possible to push relevant content and suggestions to end users. And then lastly, we have the LifeQ link, which can address things such as fitness, weight, stress management, sleep, vitals, all these different outputs. And for me, it's very important to say, it's not these individual things that are important. A sleep value on its own only gives you that much information, but contextualizing it in the other segments or verticals really gives you valuable output. To know, I am not sleeping well because of X, Y, or Z. I'm eating too late, or my exercise regime is not up to scratch. those are the things that I think really will change the way we look at health. And I think that approach, and this is not a single company approach like our company, it will be part of a consortium. We're working with a lot of data scientists, industry partners to make this happen and to create a really some momentum behind bringing medicine and bringing general consumer health together in one single package. So just some actionable insights that I would like to mention, and I'm not going to go into too much depth. I would love to. I hope there's some time for questions. But for instance, to understand what's my root cause for deteriorating sleep quality, to know whether my current lifestyle is improving my vascular health, for instance. On some of the signals, we can deduce, for instance, what they call heart health metrics, and deduce your vascular age to see whether your current lifestyle is actually improving or being detrimental for your vascular age. What should I eat based on my current physiology? And how and when should I exercise to prevent overtraining? I think I'm going to just stop there and focus on that one for a while, because I know this is a very fitness-oriented audience. It is literature, for instance, more and more show that high-intensity interval training is extremely important to boost certain hormonal levels, for longevity, for improved fitness, for instance. But it's very difficult to exactly know where's that level where I'm not in functional overreaching anymore, but where I'm reaching overtraining. A lot of devices are currently looking at things such as heart rate variability, and inherently, even though it gives clues, it's still a barometer. It gives you an indication, but it does not separate these sympathetic and parasympathetic nervous signals as well as you will get in the framework of a mathematical model. Next, I want to brush on just one other concept. It's merging worlds. We are very used to the left segment there, what we call mind-derived data, where there's a lot of people sitting here connecting their frontal lobes to a bunch of electronics, and we constantly engage with the internet with our frontal lobes. And there's this vast amount of human brains connected to the web. And I mean, this is fascinating. Look at all the things that this have brought about. You look at social media, you look at search engines that I almost don't have to search anymore. The search engine knows what I want to search. And just ways of engagement that could previously not be possible. On the other side, this is still in its infancy and something that we are working hard to achieve, what we call the body-derived data. And that is, if you realize that ultimately the actions of the mind when we engage with the web, we're not contextualized within the setting of your health, within the setting of your body, it's very limiting. These two different worlds inform each other. And it's very important to note that the mind-body connection is extremely important to give context to what people do. It was a day or two ago I read an interesting article just about how, for instance, novel research is showing that something like inflammation can contribute hugely to a disease like depression. This is really to show that very integral connection where the gut flora, for instance, of humans being so inherently different, where that gut flora has huge effects on how we deal with daily life, how we deal with stress. And our samples are very limiting because we don't have this mass, I don't want to say experiment, but this mass way of collecting information and analyzing it in a proper way. And I hope, and I am working very hard with our team. Julie mentioned 40, it's grown to more than 60 since I've spoken with her, of people working on this problem to make this a reality. So a few not so distant future insights would be, what did you search on the web that invoked the most emotion today? How does my emotional state affect my online behavior? Where can I get a meal tailored for my current physiology? Imagine walking down the street and you have a device prompting you and saying, based on your current physiology, I would advise you should grab something to eat now. Would you like to see some suggestions? where you can push very interesting and relevant suggestions to individuals based on their current state of physiology. How would a dietary intervention affect my general health? You have a digital simulation of your physiology. Now you can start doing very interesting online experiments. I want to change this digital simulations diet and see how that will affect its vascular age, for instance. Bunch of these different outputs that one would be able to derive from these models. And how do my daily activities, online and offline, affect my sleep and vice versa? So just as a last concept before, I would love to open for questions, and I would love to see it as a pretty much just a discussion where we can have a nice chat. But I think the Internet of Things, where this things really talks about sensors and talks about all these connected things connecting the real world or the physical world with the web, I think humans should be included in that. There's a few billion of these human sensors walking around, extremely sophisticated sensors. And once we have that information captured, we would be able to really understand our own physiologies and be knowledgeable about that and follow some actionable insights to address some difficulties that we have. I would like to invite you to visit our booth. It's booth 74507 at Hall C, the fitness and technology part, the SANS Expo. We are also, just want to quickly, how much time do I have, Julie, still? Enough? Huh?
Just a couple of minutes.
Couple of minutes, okay, because I just want to say something on our enabling model. What we do is we enable wearable device companies by, this is just an example device, but the technology that we've developed in this, we give to wearable device companies. And in exchange, if we have some data streams there's really interesting things that we can, through these wearable device companies and also through us enabling application developers, information that we can push back to the users there. And then we also have some fundamental partnerships. So for instance, we have a partnership with Texas Instruments. We are also in their booth where you can go and see our technology live there. At Bosch SensorTech, at Atmel, you can go there and actually see our technology in action, apart from at our booth. For us, it's extremely important to enable as much as possible. And I invite data scientists, I invite people from governments, people from all over to just join each other on this journey. And I think there's fun times ahead for us in this space, in the technology and in the wearable health space. Thank you very much.
If you're on that side of the room and you have questions for Riaan, would you mind just using that mic? And if you're on this side, I can get you.
Great speech. Thank you very much.
Thanks.
Do you just use sensors that monitor oxygen levels, or do you also do unintrusive blood analysis as well?
Oxygen saturation is one, but we can, through the model components, we can deduce some of those things. For instance, one of the things that we have modeled is the lower brain controller and how oxygen and CO2 levels actually signal the lower brain to tell the heart and tell the breathing how to react. So from these systems, we can infer those things that you just mentioned. Thank you for the question.
Hi, I'm over here. Steve from connectedrock.com. First, I want to thank you. You're one of the first people who I've heard talk about multiple sensors and not be focused on a very non-specific sensor, which is that of heart rate, or a non-specific data, which is that of heart rate. Heart rate is simply just a pump and not able to detect the oxygen consumption or the relationship of demand. My question has to do with the gathering of data, and have you run across any issues with things like HIPAA, the Health Information Protection Act?
So we make very certain that we follow all those regulations, but I was asked a very similar type question yesterday at a power session that we had. And I mean, this was a bad year for security in general. it was a terrible year. I mean, I don't want to mention names, but you all know what those names are. And there's one critical thing. I had a discussion last night, and one critical thing came out, that data protection, data security should very much be the responsibility of everyone, the users up to the people producing that data. The fact that we in our physical, in real life have police and security does not prevent us, or we still go and lock our doors and close our windows. I think we will move to that same phase in the data realm. But so far, we've made very certain that we stay within the bounds of the different regulatory authorities. I mean, that's going to be very important. For a startup like us, I mean, that's pretty much a deal breaker. So it's for our own benefit as well.
Thank you, Riaan.
And everyone can find me at my booth. I love talking about interesting stuff, so get me there. Thanks.